Hey everybody. So today I'm going to actually start having us look at some solvers to solve LPs. So we're doing our little bit of code writing. I know some of y'all are computer science majors, so y'all are used to writing a lot of code, but also some of y'all may have never written any code before. So we're going to take this at a very I'm going to teach it as if you've never used any of the software I'm fixing to show you. Although I know some of y'all have programmed in Python before, it's actually what I'm going to show you first today. Alright, so we've finished all our stuff on networks. I've given you a homework on that. I want you to make sure you do that homework, turn it in, it's due Monday. Alright, so now today, I want us to look over the next few lessons. We may look at a few computer solvers. We're just going to do a simple one today, one that's free and open source. That's why I love Python. Okay, so in Python, there's a lot of different ones you can import. Now, you don't actually have to download Python. If you do have it on your computer, awesome, you can use that. Or you can just open up a cell in one of the server pages. I like to use cocalc.com. So let me log out to show you how this looks. So here's how it looks. Let me sign out. Sign out. Yes, I clicked the sign out button on purpose. So this is how it looks. You can go to this website here. I have it in the handout for today as well. And you can sign in, or you can basically sign up for a free membership to this. Okay, that's pretty awesome. There's a lot of different ones to do this with. Let me sign in really quickly. Hopefully, I guess it has my stuff saved already. There we go. Sign in. And once you sign in, it looks like this. I'm going to, let's create a new project. Okay, we'll call it Math 305 Spring 2020, whatever you want to call yours. So this is how it will look to get a project started. Okay, that's loading your project. Now, when you're on the unpaid trial servers, it may be a little bit slower than if you actually paid to have an account. So, but I'm not suggesting any of y'all pay. All right, so awesome. Once you sit here, we can create a new file. So we're going to name it. Let's name it, maybe the same thing. Spring 2020 example, or solver example. Whatever you want to name yours. Okay, then it's going to ask what type of file. For these, I'm going to use the Jupyter Notebook ones, okay, because it lets us run Python. It's the one I'm most comfortable and cozy with. Okay, then it'll ask you to select a kernel. And we're going to select the Python 3 system-wide kernel. There's different ones. You can select all the different kernel keys, but I like Python. That's what we're wanting to use without having to download Python to our computers. All right, awesome. So here we are. And it's going to give you a cell to input code in. Now, if you've never used Python, Python's pretty cool. You can do lots of fun stuff with Python. You could be really lame and use it like a calculator. See, 3 plus 3 equals 6. But we want to do a little more with it, okay? So now here's how we actually use this to do a solver. Python comes ready equipped with some things on it, but some things you're going to have to import. Now, the reason I love Python as a programming language is it's really, it makes a lot of sense. So I want to import something, so the command is import. And we're going to import what's called scipy. Okay. Now, from scipy, I'm going to import a specific packet from it. Import optimize. Okay. Now, it won't run. The cell won't run until you tell it to run. So me hitting enter doesn't do anything. The shortcut to get it to run, where I got it to spit out 6. Was a control enter will make it run. Okay, so this inputs their optimizer, okay, their optimization software, and there's a lot of stuff there to use. We're going to use their linear program solver. So what I want to do, let me go back to the handout. We're going to do a very simple problem. Max x1 plus x2, subject to these constraints, and they're all positive variables. This is a very easy one to solve. If you wanted to solve it with a simplex or sketch it, you'd see that the optimal point's at 4, 3. Of course, the objective function value then is 7. Okay. And if you read the handout, I have stuff that I just typed in bold. So to use the solver, you need to import SciPy. From there, import optimize. Okay. And then now a few other things about this. There are a lot of options to go deep into the SciPy optimize and change things, but it gets mighty confusing, especially if you're not one of the computer science majors. You may not want to dive really deep into that. So I'll go ahead and tell you it's kind of set up to go ahead and do minimization problems, and all the constraints are less than or equal to constraints. So that's how we're going to program this. We could use it this way and always change to a minimization problem. And we could always change the less than or equal to constraints without having to know how to use the solver more. Yes, you can do a lot more deeper, cool things with this. I'll talk about in a second. Okay, so we're going to actually input our cost vector, our coefficient matrix, and our right-hand side vector. And notice that I had to change the cost vector because we're changing to a minimization problem to be able to do this. So let me go back to back here. So we're just I'm gonna call it C equals. It's really easy to input stuff here. To do a vector, you use square brackets and you put commas in between them. Okay, that's just that easy, that simple. Okay. Now to do a matrix. So this is actually the data structure is an array. To do an array, a matrix, you do an array of arrays. So we will type it this way. Let me see, what was it? 1, comma, -1 is the first constraint, right? -1. Okay, that's the end of that array. What was the next row? 0, comma 1. Oops, I forgot the beginning. 0, comma 1. Okay, notice I'm putting commas in between the rows of my matrix here. And I think we had one more constraint. What was it? 2, comma 1. Awesome. So that's a matrix. It's representing a 3 by 2 matrix. Okay. Then our right-hand sides, we'll call that B. What were the right-hand sides? 4, 3, and 11. All right. Awesome. So we have our cost, our matrix, and the right-hand side entered. It's really easy to enter those. Did not take much typing at all, much code. That's another reason I love Python. You don't have to do any fancy declarations of what type of data structure these are. I could just type them, and it knows that they're arrays. I've defined them as arrays. So now, the way we call on our optimization software is we're going to go SciPy dot optimize dot, and here's where we're going to call on linear programming, linprog. And then we're going to use the C, A, and B to input things in. So literally just parentheses, I can put C, A, B with commas in between them. And then we have to type one more thing. We have to tell it how we want it to solve. So we're going to go method equals single quote simplex. Okay. This has different solvers in it. It'll do different methods. It'll do interior point methods and combinatorial methods and all sort of stuff. We just want to do the simplex here since that's what we've studied and we know that's a pretty good method for solving things. Okay, so that's actually all the code we need to get the optimal. Now all the outputs here are actually fairly interesting. So I'm going to hit Control Enter and it will run my code for me, assuming it did not make any mistakes, and it will give you all of this stuff right here. I want to point out stuff. I'll start at the very bottom. It gave me the array 4, 3. Well, what was the optimal solution if we go back and look? I have it written right here. Oh, it was 4, 3. That's awesome. It picked up the optimal. It actually worked. Notice also the objective function value should be 7 because, you know, that's what we're maximizing up to. But wait, it gave us -7. Why is that? That's because we had to convert it to a minimization problem, remember? So this is opposite of what the actual objective function value should be, so -7. That's what the fun means, is the function value. So it gave us all that stuff. Now I want to point out a few other things that it gives you. It gives you the slacks. Do you see that? The slacks on the constraints being 3, 0, and 0. Well, let's go back and look at the original and see if 3, 0, and 0 makes sense. That's actually really neat. So what were the points? 4 and 3 was optimal. 4 and 3, and you're going to add those slacks, right? Slack 1 is going to take on a value of, what was it, 3? Was it 3? I think it was 3. So 4 minus 3 plus 3 is 4, because the slacks make it equal to. The slack here was 0, and the slack here was 0. Let's see. So these two must be binding constraints. If the slack's 0 and the slack's 0. Let's see. 2 times 4 is 8, plus 3 is 11. 3 is equal to 3. So those are tight constraints, binding constraints. This one was loose, so the slack actually took some value there. So it tells you the slacks. How awesome is that? Okay. There's other output you can suck out of this thing. It's really easy to print things. See if I can get it to print something. Actually, let me add a new cell. So if you hit the plus on here, it'll add a new cell to type some more code in. Printing out output's really easy. Let's see if it saves that as that. Let's see if it takes that or likes that. Nope, it did not define it as X. I thought it would steal the X from here. But anyways, you can print things just by print in parentheses. It's really awesome. Okay, so there. Now, if you do want to dive really deep, you can actually go, I love Python because you can always type help and then type what you're using in parentheses, scipy.optimize. Whoops, if I could spell, .optimize.linprog. Okay. Actually, if you then run that, control enter, it's going to give you a whole section on how to use it. So notice you don't have to do less than or equal to constraints. You could do equal to constraints. There's all these different things you can do. You can bound the X so that it's in between an upper bound and lower bound. There's a whole lot of explanation here of all the things that you can do. All right. So I do want to let you know that you have the option to dive deep if you want to. If several of my computer science students usually express to me that they want to see more of the solving side, the solvers, and dive deep into those. So we introduce the optimization, and then near the end here we start playing with a few solvers just to show you some. All right, so it's actually really easy to use. Now listen very closely. I'm thinking about giving you a homework where I have you do this as well. Solve one or two really easy. Maybe we should do some interesting ones just to see what your output is. Maybe with alternate optimals, and see if you could make it give you the different optimals, or if it would notice that there are alternate optimals. Kind of let you do some exploration with this. Okay, I think I'm doing a homework where I want you to do it in Python like this, and what I would ask for is your code and your output. You can literally just copy and paste this into a text file. You know, what are some the Windows one, Notepad, and or you could copy and paste it and try to let's see, could you paste it into, you might can convert things into a Word and then turn it into a PDF to upload. But I may send you a homework in a few days once you get the network homework done to have you solve one or two problems and maybe do some interesting ones. Let's see what happens when there's alternate optimals, or when it's unbounded. What's it going to tell us when it's unbounded? That would be pretty interesting. So those are things. So this is fun. I want you to play around with it. It's really easy to use this solver in this way, as long as, remember the important things, you have to make it a minimization problem, so I had to flip the signs, and I had to have all less than or equal to constraints. I do want to ask you, what if one of these were a greater than or equal to constraint? That's a really easy fix as well, right? Just multiply through by -1. And that would flip the inequality. Of course, all these signs would flip as well, and it would become less than or equal to. So that's an easy fix. The other thing is, what if this were equal to 11? Well, I could write two constraints. So I could do 2x1 plus x2 equals 11. I could write it as less than 11 or greater than or equal to 11. Less than or equal to 11, and then write another one that has to be less than or equal to 11. And then I would have to multiply the greater than or equal to by negative. Get them all as less than or equal to constraints, and that should work as well. So maybe we should solve one of our networks. That would be awesome, because you would have to, now you'd have to do a lot of work there. You'd have to write the network as an LP. Then you would have to make all the constraint less than or equal to. Now the way to do that would, like I said, write it as a greater than or equal to and a less than or equal to the same number, and then flip the greater than or equal to one. I don't know. I'm thinking about how I want to write up this homework. I may ask for that. I may do other things. But in a few days, I'll send you a homework, maybe on Monday, since the other homework's due on Monday, to where I have you play more with this solver. And in the meantime, I suggest you go and you try this. When you watch this video, I suggest during or after you pull up a Python page like this and you try it. Okay. It's pretty fun. You can try different problems. You can pull up problems that we've done earlier in the semester, look back in your notes and see if this works. Play with it and get cozy with it. Okay. Next time I'm thinking of showing you some other solvers. I'm not sure how deep into the coding I want to get, but I want to show you maybe a commercial solver or two that's used by big industries. And those are on my other laptop, but maybe I can just show you some of the software. They're pretty interesting as well. But that's all I have for you today. We're going to stop there. I want you to try this. I'll send you a homework in a few days for you to play with it. Now, you'll have an awesome Friday and an awesome weekend, and I'll talk to y'all again on Monday.